fabricated on the IC chips. Okay, simple and expensive. Okay, and safe. That is the advantages of the digital techniques or digital system. And then the limitation or disadvantages of the digital is the real world physical quantities use analog lah. And then another one, the digital processing take time. Okay, to convert from analog to digital, they have some process that will be we have to consider. Okay, that's why the process to convert from analog to digital will be take time lah. That's why the digital processing will be take time. So that is the disadvantages of the digital lah. So I will.
So are you moving the slide?
No. I will share another one because this one I cannot write. Okay, I cannot write. So I will share the another one. So don't worry. I will share.
Okay, doctor. Thank you.
Wait. I will share the new slide. Okay, because this one I cannot write on this slide. So I cannot write anything. So this one I will try to change another one. So I will try to share. Alright. So can you see my slide here? For the
yes.
Okay. So
Yes,
this one I
see.
okay. So the rest I will start down first. Okay, this one don't need. Okay, don't need. The menu. Alright. So can you see this one? Okay. So next for chapter 1 is part 2 is the numbering system and codes lah. Okay. So you can see this one. So the numbering system digital code are fundamental of the computer and digital technology. So actually we have a lot of numbering system and digital code, but we have 4 most common numbering system, okay, such as decimal. Decimal is the base 10. That means it's a normal number that we use. Okay, 0 until 9, then 10, 11, and so on. So that is the normal Decimal is the normal number that we use for daily activity. And then another one we have the binary. Binary we have based on 2 Base 2, that means we have 1 or 0. Okay, so that is we call binary. Or we have another one 1 1 0 0 1 1 0. Okay, so this is called the binary based on 2. That means either 1 or 0. And then we have the octal. Octal base 8. That means from 0 to 7. Okay, then will be repeat again right. So that is based on 10. Okay, based on its octal. And then another one is the hexadecimal. That means base 16. Okay, base 16. That means from 0 to 15, then repeat again. Okay, repeat again. Right. So this is 4 common numbering system for digital technology and computer. So normally that I mentioned to you, we use the decimal base 10 We use the normal for every day we use the normal numbers. There is decimal. We call it decimal. Okay, we go one by one. Alright, so decimal number that I mentioned to you is the base 10. That means from 0 to 9 and then repeat again. Okay, that means we have 10, 11, and so on. Okay, so you can see this one. So actually, this is the number of sequence. The sequence of the base 10. So for example, we have 10 power of 0. That means 1 here, and then 10 power of 1. We have 10. Then 10 power of 2. Okay, 10 power is 100 and so on. So 10 power of 3, that means 1000 and so on. Okay, and then if less than 0 here, so will be negative 1, negative 2, negative 3, or you can write like this. Okay, 1 over 10. Okay, or this one, 1 over 10, or 1 over 10 power of 2. This one 1 over 10 power of 3. Okay, so this is you can see. So this one normally here we call the most significant bit. Sorry, this one least significant bit, and this one we call the most significant bit. Okay, significant bit. So this is a sequence for the base 10. I think all the number will be same lah. For example, like this octal, hexadecimal, but the difference is this one lah. So for example, for hexa is a base 16. So that means 16 power of 0, 16 power of 1, 16 power of 2, and so on. Okay, if less than 0, 16 power of -1, we start at -1, 16 power -1, 16 power -2, and so on. Okay, that is for sequence for the numbering system. All right, so next we go for binary. Okay, the binary based on 2, okay, that I mentioned to you. So only we have 2 digits, there is a 0 or 1. Okay, this is a sequence for binary. Okay, start from 0 to until infinity, and then this one will be start at -1, okay, -2, 2 power of -3, and so on. Okay, and then you can see this one that I mentioned to you. So here normally we call a less significant bits, and then this one is the most significant bit. Okay, but if less than 0, that means here will be more significant bits, and then this one will be less significant bits. Okay, less significant bit less significant bit. So you can see this one. For example, this one, okay, we call the most significant bit, and the small one we call the least significant bit. Okay, so you have to know lah. So which one the most significant bit and which one the less significant bit lah. For example, if we took decimal point, we ignore the decimal point. So this one will be our less significant bits. Okay, if we ignore this one, ignore the only consider this part. So this is we call the most significant bit, and this one will be our less significant bits. Right, so next we go for the octal. Octal base 8 that I mentioned to you. That means from 0 to 7, and then will be repeat again. Alright, so this is a same. Okay, the sequence for octal start from 8 power of 0 until infinity, and then so on like this. So will be 8 -1, 8 -2, 8 -3, and so on. Okay, so this one will be similar like before this. I mean 1 over 8 will be 8 power of 1. Okay, so this one 1 over power of 2, 8 power of 2, and F3. Okay, so this is you can write like this or you can maintain like this, but will be similar lah. Okay, so this one will be octal. We call the octal. Octal will be based on base of 8. Okay, next is the hexadecimal. So hexadecimal base of 16. Okay, that means to you is a 16. Hexadecimal is 16. This means from 0 to 15. Okay, this one 15 lah. So and then we will convert into the hexadecimal. We use the F. We use the F here. So after 9 will be use the A until F. Then repeat again 0 until that we call the base of 16. Okay, so that they will be same lah. The sequence of the hexadecimal. Okay, but the difference is the power is this one. The base lah. So this base we use the hexadecimal is the 16 lah. So for example, less than 0, 16 power of -1, 16 power -2, and so on. Okay. So also you can write like this. You can write 1 over 16. Okay, this one 1 over 16 power of 2, 1 over 16 power of 3, 1 over 16 power of 4, and so on. Okay, that is a sequence. Sequence for hexadecimal. Every numbering system will be same lah. Will be same concept. Will be same concept, but based on the what? Okay, for example, octal will be based on 8. Okay, this one based on 8, and then binary based on 2, and then decimal based on 10 lah. Okay, so that is the some definition on the hexadecimal. Okay, hexadecimal, octal, binary, and decimal. This is the 4 basic most common number system for our digital technology that you have to know lah. Alright, so next, this is some example, the conversion table. Okay, so that's why I have already mentioned on the group. You have, suppose you have the calculator. So actually we can use the calculator lah, to convert from decimal to binary, or decimal to hexadecimal, or decimal to octal, or octal to hexadecimal, or octal to binary, and so on. Okay, you can use the calculator straightforward. We can use the calculator lah. Alright, but after that I will show the manual step lah, how we can convert from binary to, for example, the number system of binary to hexadecimal, or hexadecimal to binary, and so on. Okay, so for that, I'm not sure. So you already know how to use the calculator, your calculator. You know or not? How to use the your calculator to convert for the numbering system? You know or don't know? Maybe you have learned. I'm not sure. I'm not sure you already learned before this or not. So how to convert? Okay, how to convert from, for example, decimals to binary? You know, using your calculator.
Yes.
Okay, so I think no need to explain. Or you want to explain? Okay, hopefully, some I hope you know, but maybe we can refresh lah. Maybe we can refresh how to use your calculator. How you use the calculator. So if you have a calculator on your, okay, you can try. So my calculator, I use this my calculator version. So I use the FX 570MS. Okay, this is my calculator lah. But this is old version. I use the old version of calculator for this series of the calculator. But the latest one, I think if you have, suppose you are buy the later one lah. Okay, the latest version of FX 570, because for the old version we have the limited on the binary. Okay, binary. So maybe just, I'm not sure. So maybe around you can change. Okay, maybe we have until, I think, until 8 bits. Okay, if you have 12 bit, for example, 12 bit. Okay, for example, we have 1000111001111. Okay, for example, so we have, for example, we have 12 bit here. So the old version cannot convert because they have some limited. Okay, limited on the sequence. Okay, maybe they are limited on 8. Okay, 8, or I think maybe 12 bits. Okay, only. So that's why all the, for example, the new version of the calculator, you can convert, I think, until 16 or 20 bits of the binary, for example. Okay, that is limited. That's why if you put a lot of, for example, more than bit, I think you can get the mathematic error. Okay, that is the for all version of the calculator. Okay, so maybe I just refresh. Maybe some of you not remember how to use your calculator to convert from decimals to binary, for example, decimal to hexa, decimals to octal. Just refresh lah. Okay, before we go for manual converting using the every techniques to convert from decimal to binary, decimal to hexa, and so on. Okay, so if you refer to your calculator, all right, so if you use same calculator lah, say FX 570MS, okay, all version. So you can press the mode. You press the mode here, or you put mode button and you put here clear. Okay, you press, I think, okay, 2 times. Okay, 2 times. Press 2 times, so you will be appear like this. Okay, your calculator will be appear like this. SD. All right, on 1 here, and then RSG number 2, and base. Base will be 3. Okay, and then you have to focus this one. You have to press 3, number 3. Press number 3. Okay, when you press number 3, so will be appear lah numbering system. then you can convert. For example, you want to convert from 15, okay, 15 to binary. So you just substitute 15, 1, 5, and then press on the binary, okay, on the binary. Binary, you can see on the log lah, okay. For example, decimal, okay, decimals, okay, decimal. Based on your calculator, this is the symbol that you have to press lah, the x power of 2. Okay, x power 2. You can see above they have the indicator here, decimal, and then another one will be these symbols. Okay, will be this one for hexadecimal. This one to convert hexadecimal, and then we have log here. Log here you can see is the binary. It's the binary. Last one will be non. Okay, so this one will be convert to octal lah. Alright, so this one formula, you can see the symbol of this one. You can press either you want to convert, for example, you want to convert from 15 decimals to binary. First, you have to press 1 pi and then click here lah on decimal. Then you can change to, for example, you want to change to binary. Okay, click log. Or you want to change to octal, just click on the this symbol. And then for A, okay, for example, like you have this one, this symbol A. So you can see on this symbol lah, okay, on your calculator. So we have this one symbol. You can see on the indicator here will be A, and then another one will be this symbol. You can see on your calculator. Okay, so this is for B and so on, until you can see that, okay, this one we could call a tangent. Alright, so this one will be F lah. Okay, so this is represented for this value, for this value A, B until F lah. Okay, for example, this one will be hexadecimal. For example, you have this value for A or B, so you can know where to press. So this one, based on your calculator lah. This one all version I'm not sure for the I think will be similar. Will be similar for the latest version for the FX570. I think if you have if not buy the calculator, so better you can buy the latest one because the latest one, for example, the advantage of the latest one, you can solve the for example this one that I mentioned to you. So the bit for the old version, they have the limited of the number of bits. For example, this one maybe we have, for example, we have 12 bit, 12 bit. Maybe old version around 10 bit only. For example, this I'm not sure. I forgot the numbers. And then, but if the later version, maybe you can convert more than 20 bits, for example. Okay, and then another example, you can solve the integration. Okay, for example, we have the integration. This some example. 1, 0. We have x power of 2 dx. Okay, this is integration plus 2 of 3. We have the x power of 3, for example, and then we have a 4 and 2. Okay, this is x power of 3 minus 1 minus 4, for example. So if you use the old version, you have to solve one by one. That means first you have to solve this one, next solve this one, and next you can solve this one. But if you use the old latest version, you can solve all in one press, in just substitute the value and in one step lah. No need to do okay, you have to solve this one first, next solve this one, and plus this one, and so on. Okay, so the old version you have to solve one by one lah. Okay, right. So next we go for the numbering. Okay, numbering system conversion lah. So that I mentioned to you. First step, you can use your calculator lah to convert from binary to decimals, binary to hexa, and so on. Okay, you can use directly using your calculator. Right, so actually depends on the question. So for example, okay, we have some example. Okay, for example, we have the binary 1 0 1 1 0. Okay, so convert into decimal. For example, this is binary, convert into decimal. Right, so if you can see the mark is 2 marks. Okay, for example, 2 mark here, so automatically you can use your calculator. No need to use the manual because of the mark, for example. But the question is maybe you can see here will be 4 marks. That means you have to use the manual lah. You have to use manual. You have to show the manual, then you can get the last result. What is the output here? What is the decimal number here? Okay, so that means you have to show the step lah. Show the step. Don't need show the step from binary convert into manual using the convert to the decimal using the manual lah. Manual method, not to use the calculator. But you can use your calculator to verify, okay, to verify the answer lah. Is it correct or not? Sometimes we do some mistake lah because I mentioned to you. So this subject is easier to do a mistake because of so maybe we just some mistake lah, simple mistake. Maybe just write like this. Maybe the missing one here or the missing the more than one zero here. So for example, so this some mistake lah. No, it's a common mistake. Okay, common mistake. That's why you have to verify your calculator. So but depends on the marks lah. For example, marks only 2 marks. So just straightforward using your calculator. No need you spend your time to do the manual lah. Okay. But you have to know, you have to know the manuals, okay, using the manual, how to convert from binary to decimal, for example, binary to hexa, or hexadecimal to decimal, or hexadecimal to binary, and so on. Okay, so today we focus on this one, numbering system lah, conversion. Alright, so this is binary to decimal lah. So that I mentioned to you, Alright, so you can use straightforward using your calculator. Alright, so this one, straightforward 10, or you can use this one. For example, okay, as I mentioned to you, so we have this is sequence for 0, 1, 2, 3, 4, 5, and so on. Okay, so you can see this one. So will be 1, 1, 0, 1, 1. Okay, that's why you can see here. So and then you know. So this one will be 2 power of 0 will be 1. Okay, this one will be 2. This one 2. This one 4. This one 8. This one 16, and so on. Okay, so on. Okay, you can see this one. So 16 times 1. That's why you can get here. And then this one 8 plus 8. Okay, multiplied by 1. Okay, this one 0, okay, because 0 here, and then 2 multiplied by 1, okay, that's why you can see this one, 2 multiplied by 1, and then plus 1 multiplied by 1, alright, so, and then you substitute this value, okay, plus this value, so you can get the total, total is the 27 decimal. Right, so this is a manual, so maybe you can try another one, okay. For example, we have the 1, 1, 1, 0, 0, 0, 1, 1. Okay, you can try this one. Okay, first you can verify using your calculator. Okay, for example, if you can use a calculator, okay, 1, 1, 1, 0, 0, 0, 1, 1. Alright, so what is the on the decimal number? Okay, what is the decimal number? Anyone get the answer for the decimal using your calculator? Okay, 227. Okay, power of 10 okay, decimal in decimal So this is using your calculator. Alright, so you can verify You can verify using this manual and then verify with this answer Is it correct or not? For example, alright, so we have this one. We have power of 0, power of 1, power of 2, 3, 4, 5, 6, 7. Okay, so 2. So this one will be right. So normally this one will be 1, 2. Okay, this one will be 4. Right, and then this one 8, 15. All right, 32. Okay, 54 and 126. Okay, and then just okay. So 1 multiplied by because we have 1 here. 1 multiplied by 142 plus 64 plus 32. All right, 0 plus 0 plus 0 plus 0, plus 2, plus 1 lah. Okay, so the total will be 227 in decimal lah. Okay, so that is the manual lah. That is manual method from convert the binary to the decimal. Okay, for this one, but you can verify lah. You can verify using your calculator. So maybe you can do simple mistake lah. That's why you can verify using your calculator. Okay, so this is some formula that you have to remember. Right, so from converting decimals to binary, you have to divide by 2. Okay, this is a manual. So, for example, we have 10. Okay, we have 10. So, you want to 10 decimal. In decimal, you want to convert into binary. Okay, so we can divide by 2. Okay, we can divide by 2. Right, and then, for example, from binary to decimal, we can multiply by 2. Okay, multiply by 2. This is some formula lah. Some formula. For example, like decimal to octal, you can divide by 8, okay, and then decimal to hexa, we can divide by 16, okay, or okay. So for example, like octal to decimal, we have to multiply lah. This one divide, and this one, for example, binary to decimal, we have to multiply by 2, multiply by 2. Right. So this one, for example, like this one, okay. For example, this one, okay. This part actually you can use the calculator. For decimal point, for this one you cannot use the calculator. Okay, this one, I'm not sure you can use. I think the old version cannot use. I think the latest one also cannot use if you have the decimal point. So this one, okay, this part we can use the calculator straightforward. Alright, but this part you cannot use. Okay, you cannot use because of the limitation of the calculator lah. So this one we have to use the manual lah. For example, the manual so we have 1 0 0 1, okay, point 0 1. Okay, this one will be 2 power of 0, 2 power of 1, 2 power of 2, 2 power of 3. Okay, so this one will be 8. Okay, and then plus 0 plus 0 plus 0 plus 1 lah. Okay, dot. Okay, this one will be power of -1. Right, so and then this one -2. Alright, so this one will be 0 and then plus. Right, so 1 over 5 lah. Okay, 0.25. Okay, so the answer will be 9.25. Okay, that is some answer lah, that you have to know. Okay, so that is the solution lah. You can see this one. So this is the manual lah. So this part you can use a calculator. For example, if you have a calculator, you can straightforward. But this one, you have to solve using the manual lah. So this one, alright. So this part. So you have to know lah. So for example, we have decimals. Okay, this decimal we have. For example, for binary, binary we have 1 0 0 1 1. Okay. So that means here we have the power of 0, power of -1. This is power -2. This is -3, and this is the -4. Okay, alright. So 1 power of -3 is 8, and then plus 1 power of -16. Okay, so that's the answer for this one, for decimal point. Okay. I think for this one is straightforward. The numbering system is straightforward. Okay, next we go for the binary to hexadecimal. Alright, so for the hexadecimal, okay, you can see this one. This is some trick that we can use. Alright, for this hexadecimal, if binary to hexadecimal, you can group by 4, or you can split by 4. For example, 4 bit 1 2 3 4, we can split one group. Okay, 1 2 3 4, we can split one group. Right, so this is for binary to hexa. For example, if binary to octal, you can split by 3. Okay, for example, if this one hexa, we split by 4. Okay, make sure you start from, okay, the hexadecimal, you have to start from this one. You have to start from least significant bits, then go for the most significant bits. Okay, we have to start here. You cannot start from the most significant bit. For example, if you have similar like this. Okay, maybe you can this one is the, if we divide by 4 we can get the same lah. For example, we have 0 1 1 0 0 1 0 1 1 1 1. Okay, so if we divide by 4, if you divide from more significant bit, we will get the wrong answer lah. Okay, for example, if you divide by more significant bit, so this one will be one group. Right, so this one 1 2 3 4 will be one group. So this one will be so that's why you have mistake lah here. So that's why for to split by group, okay, for the binary to hexa, make sure you split from the least significant bit first. Okay, that means here 1 2 3 4. Okay, this one group. Okay, this one group. Okay, and then 1 2 3 4. Okay, this one group, and then this is the last. Okay, only 3, and then we can add another 0 here. It will be same lah. Right, it will be same answer because it don't this one is not effect. Okay, that's why for the grouping, make sure you start from the least significant bit, not from the more significant bit. Okay, make sure this one. Maybe there is some mistake lah. The previous student, the grouping on this. For example, we have okay, maybe here. So for example, we have 1 1 0 0 1 0 1 1 1. Okay. So if you convert from the more significant bit, okay, maybe you can write like this. So 1 1 2 3 4. So and then the answer will be wrong lah. Okay, you have to start on the least significant bits. Okay, least significant bit this means 1 2 3 4 one group, then 1 2 3 4 this is another one group, and then this is the last part lah, the last part. Okay, for example this one, okay, this example, okay, so we split by 4 bits. Okay, that's why this one we can get the this one is the 111. So you can use your calculator or you can direct pass this one. Okay, that's why you can get F to B. So the answer will be B to F lah. So this one will be from binary to hexadecimal lah. So maybe you can try. Okay, maybe you can try another example. I will write here, so you can try using this. We have 1 1 1 1 0 1 1 1 0 0 1 1. Okay, so this one from binary to hexa. Try this one. Okay, try this one to convert. Okay, for example, you can first you can use your calculator. Alright, so to verify your answer. Alright, so you can try your calculator lah. Try first. Okay. Alright, so you have the 1 1 1 1 0 1 1 1 0 0 1 1. Alright, so my calculator cannot use so because of the my calculator cannot use because we got the mathematical error because of the limited bit for this calculator, so we cannot use. Okay, so maybe if you have the latest version, you can solve this one using your calculator. Alright, so for example this one that's why I mentioned to you. For example this one, if you use your old version calculator, you cannot solve. It's not a problem on your this one is a problem on the system lah, because this we have the limited, the old version they have the limited until I think until 8 bit. Okay, 8 bit or 10 bit lah, for example, to solve the binary to another number system lah. Okay, for example this one we have 12 one, we have 12 bit, so cannot solve using old version of the calculator. If all latest version you can solve. Okay, for example we have to use the manual lah. Manual, you have to start from least significant bit. You have to put this one. Okay, 1 2 3 4. Okay, and then you have to convert lah. So this one will be F. Okay, and then 0 1 1 1. Alright, so to hexa. Okay, so this one will be 7, and then binary 0 0 1 1. Alright, so to hexa will be 3 lah. Okay, so this is the hexadecimal this binary convert to hexadecimal. That is the output so in hexa. Okay, make sure you put the symbol here, the 16. That means this is represent for hexa. Okay, hexa. Right, so next we go for the, okay, so you can try this example All right, so you can see I mentioned to you for decimal point. For this one, we have to start here. Okay, we have to start here. All right. For example, for the decimal point, we have to start from this point. Okay, that I mentioned to you. So this is more significant bit for this decimal point and this significant bit. But for this one, for decimal point, we have to start from this point. Okay, this means 1, 2, 3, 4. All right, so this is one group and this is another group. Okay, for example, this one, 1, 2, 3, 4. All right, so one group, and then 1, 2, 3, 4, that one group. Okay, then you can get the answer lah. This one group lah. Okay, so that is the how to convert from binary to hexadecimal lah. Okay, make sure you put the correct group. For example, for this one, this is very important. So for this one, you have to start from least significant bit here, then go for the most. But for decimal point, you have to start from this point first, from most significant bit to the least significant bit lah. Right, so this is the answer. You can see this one. Okay, 1, 2, 3. Okay, so that's why you can put another 1, 0 here. Okay, and then this one 1, 1. Okay, then another one. Okay, that's why I convert into the hexadecimal. This one we can get A, B, and D, and then this point. Okay, this one will be 5, and this one will be A. Right, so because of this one will be introduced, we introduce another 0 here. So that's why you can get A here. Right, so this point you can use your calculator actually. Okay, this one you can use calculator, but this one you have to use the manually. You can use the manually. Okay, this one to binary to hexadecimal. And then you can see binary to octal that I mentioned to you, you can divide by 3. Okay, that is the difference between the octal and hexadecimal. For hexadecimal, divide by 3 groups. Okay, one group by 3 bits. Okay, 1, 2, 3. Okay, this one group. Okay, 1, 2, 3. Okay, this one another group. Okay, 1, 2, 3. Right, 1, 2, 3. Okay. Okay, so here this is our group. Then you can convert 101 will be 5, okay, 7, 2, 1. Right, so this is a value okay, for octal. This one how to convert from binary to octal using the manual method. Okay, we can use this one okay, from split by group one. Okay, for octal one group is a 3 bit Right, so okay, you can try this one example. Alright, I will show the example. So you can use your calculator straightforward, but this one is the manual 1, 2, 3. So this one value 1, 2, 3. This one value, and then you can convert lah. Alright, you can convert using the calculator, or you can straightforward lah. Okay, so this is the answer. Okay, 256 and octal. Alright, so actually to convert decimals to binary, we have two methods. Okay, using this I already explained to you. This one, I already explained to you. And another method, we can use the reverse process, or we can divide. Okay, we can use a division. Right, so this is another example. An example from decimal to binary. You can use this one. You can, up to you lah. Which one you are familiar. You want to use this one, or you can use another techniques. Another technique is a division. Okay, we divide by 2. Okay, because of the binary binary, we have to divide by 2. If decimal to octal, we have to divide by 10. If hexadecimal, we have to divide by 16. That is the another method using the division. Divide by decimal point, decimal number by 2 lah. Alright, there is some example here. Okay, you can see this one will be same. Alright, so 35 okay here. Alright, so divide by 2. Okay, this one is a 12, and then we have a remainder 1. Okay, because it's 24 and 24. Alright, so 25 minus 24 will be remainder here 1 Okay, remainder will be bring remainder here, and then divide by 2. 12 divided by 2 will be 6, no remainder. Okay, no remainder here, and then 6 divided by 2 will be 3. Okay, here will be no remainder. And then you can see 3 divided by 2, we have 1, and then but we have 1 remainder here. And then this one cannot remainder, so just bring 2 here. So this is our numbering system, but you have to read from most significant bits. Okay, this means the answer will be 11001. Okay, so that's why you can see. So the first remainder is the least significant bit, and the last is the most significant bit. That's why you have to read like this. Okay, from most significant bit to less significant bit, least significant bit lah. This means the sequence will be 11001. Okay. So that's why I prefer to the previous one. I prefer you use this one, this method. Okay, this technique lah. I think this technique is very simple compared than division. So division, some mistake happen to before this. I think maybe can repeat again the same mistake. Maybe you can write like this: 10011. Okay, so will be wrong answer. Okay, for example, this one. Okay, that's why I mentioned to you. So if you get this answer, please verify using your calculator. Is it 25 or not? So if not get 25, so that means your division is wrong. Okay, your method here or your calculation here with is something wrong here lah. That's why you have to double check again. That's why I mentioned to you. So if you use this technique, okay, divide by 2 or divide by, for example, you want to convert into octal or hexa, divide by 16 or divide by 8. Make sure after you get the answer, verify. Okay, this one verify using your calculator lah. Okay, verify using your calculator. Okay, and then check, is it 25 or not? Okay, if not, so maybe you can double check here. For me, I'm better. My suggestion, better use like this lah. Okay, I prefer use this one because it's straightforward. Because so you know, 16 plus 8 plus 0 because of, and then plus 0 because you want to get the 25 kan. So that means you have get 25 lah. 16 plus 8 plus 1. So automatically you get the 25. So this one will be 11001. Okay. For me, I prefer you can use like this lah. I think this is a simple method compared than you use this one this technique lah. But up to you. Okay, up to you. It's okay. For me, it's which one you are familiar lah. For me, my suggestion, you can use this one lah, this technique. This technique, I think, straightforward and simple lah. And then student less do the mistake compared than using the divide here, this technique lah. Okay, so this is another technique. We have the decimal point, alright. Okay, so how to convert? Okay, this one I think you can use the straightforward, similar like before this. Okay, similar like previous. Okay, this one 3 2 divide by 2. Okay, so this one you can do the same process and then to get the name. But this one I want to show this one for the decimal point. Okay, that means we take here 0.372. Okay, this one you have to multiply by 2. Okay, multiply by 2. Okay, so 0.375 multiply by 2, you can get 0.75. Okay, 75. That means you bring the 0 here. Okay, bring here to right, and then multiply by 2. Okay, so multiply by 2, 0.75 multiply by 2, you get 1.5. So 1.5. Okay, 1.5. Actually, this one bring to this one. Alright, so will be 1 here, and then this one will be 0. Okay, 1 bring to here, and then this one will be 0.5. So multiply by 2. So 0 multiplied by 2 will be 1. Multiply by 2 will be 1. So 1 bring to, okay, bring to here lah. So that is the answer. Right, similar dimension here. So this is the answer. That's why you have to read. Okay, this one. For example, this point you have to read from most significant bit to least significant bit. This means you have to read from this point. 1 0 0 0 0 0 1 1 0. Okay, but for this one you have to read from most significant bit. Okay. from this point to this point lah. That means the answer will be 0, 1, 1. So that means you this one. Okay, right? 0, 1, 1. Okay, 0, 1, 1, 1. Okay, this is the I mentioned there the technique. So 0.375 multiplied by 2. Alright, so you can get this one. Okay, 0.75, and then bring 0 here, bring to front here, and then this 0.75 multiplied by 2, you can get 1.5 kan, 1.5. Okay, 1 bring to front. Okay, and then just bring just left the 0.5 here, and then 0.5 multiplied by 2 will be get 1. So 1 bring to front, so will be this one will be 0 lah. So that is the answer. Okay, so maybe you can try another example. Okay, we have another example. Alright, so this one. Okay. Alright, so this one for hexa. Okay, for hexa will be same. This one will be same lah. You can use this technique. Divide by 16. Alright, divide by 16. Alright, so this one you can use this one. Same like for binary or for octave. Okay. For this one, for the hexa, we have to multiply by 16. Okay, multiply by 16. Okay, for example, our decimal point will be this one. Okay, just bring this value and then multiply by 16. Okay, multiply by 16. You can get the answer will be 5.25. Okay, so you can try using your calculator. That's why you have to make sure you have to your calculator inside you, so beside you, so you can try. Same with me. Okay, try. Okay, you can do same with me lah. Same. Okay, try. You can also try to prove that the answer is correct or not. Maybe some typo. In I think after this you can see the typo lah. Typo in our slide. That's why you have to make sure you have to follow me lah. Check. Okay, you have to use your calculator to double check the answer lah. Okay, for example, 0.32825 multiplied by 16. So you can get the answer will be 5.25. So the front 5 here, I will bring to front here. Alright, so and then will be left the 0.25. And then 0.25 multiplied by 16, we get the 4. Okay, 4 here actually. 4 I will bring to front, and then will be left the 0 here lah. And then the output will be 54. Okay, 54. We have to read from the most significant bit to least significant bit lah. Okay, this one is some example lah. Some example. Right, so this one you can check. Alright, so convert from 120 decimal into the hexa number, hexadecimal number. So the answer will be 78 lah. So this one you can try. Okay, so this one similar. Alright, so this one from hexadecimal to decimal. Okay, you can use this technique lah. Alright, so I mentioned to you. So this one, okay, for example, I read like this: A, B, 5. Okay, this one will be 16 power of 0. 16 power of 1, 16 power of 2. Okay, this one you can see this one. 5 multiply 1. Okay, this one 5 multiplied by 1. Then this one B multiplied by B, I think is 11. B is 11 multiplied by 16, and then A 8 is 10 multiplied by 60 power 16 multiplied by 16. Okay, multiplied by 225. Okay, so that's why. And then you total up so you can get the sum of these numbers lah. So the decimal number is the 2741 lah in decimal number. Okay, so this is a manual lah. You can double check using your calculator. That's why after you do the manual calculation, for example like this, okay, make sure after this you have to verify using your calculator lah. Whether you can check whether you can use which one correct lah. Suppose the calculator is right, but you have to double check. Okay, if you get the different answer between your calculator and your calculation, so you can check your calculation lah. Maybe some mistake on the plus or some mistake on the multiply. Okay, So that's why you have to verify using your calculator. Okay, so okay, here, so you can try this one. All right, so you have the this one, so this one, okay, so you can solve this one first, okay, and then you can solve this one. I will show this one and this part. This one you can, okay, for example, we have b4, this one will be 16 power of 0, this one 16 power of 1. Okay, that means b is the 11 multiplied by 16 plus 4. Okay, plus 4. Okay, so 11 multiplied by 16. Okay, plus 4. Total is the 180. Okay, 180. This one, 180, and this part will be C2. Okay, C2 will be this one 16 negative 1, and then this one 16 negative 2. Okay, power of negative 2 lah. So, or you can write like this: 1 over 16, okay, multiplied by C plus 1 over 6 power of 2 multiplied by 2. Okay, and then you can try lah. You can check the answer. Is it correct or not? Okay, this one I think we have some typo here lah. I think the answer will be here will be 8. Okay, 5 7 5 7 5 7 8 1 2 5. Okay, so this is some typo lah. You can double check here. The answer, for example, okay, C is the 13. Okay, divide by, for example, you have 1 over 1 divided by 16. Okay, multiplied by C is the 15. Okay, B is the 11. Okay, 0. Okay, this one will be 0.75. Okay, plus 1 divided by 260, 255. Okay, multiplied by 2. All right, so the answer will be 7 8 125 multiplied power of negative 3 lah. So just plus, so the answer will be 7 5 7 8 1 2 5. Okay, so this is a mistake lah. Okay, that's why you can double check. So the answer given in the slide, so maybe you have some typo, that's why you can double check the answer. Okay, so this is a hexa, okay, hexa to binary. Okay, that means you can, okay, for example, this is another example. All right, so for example, for binary, you can divide by 4, and divide by 4, and then this one you can do like this lah. Okay, for example, you bring like this. Okay, this one 2, one A, one F, one D. Okay, and then similar like for decimal point lah, 5 and A, and then convert into the binary. Okay, for example, this is 2. Okay, this is some mistake. This one, alright, so 2. Okay, yes. Okay, this one, okay. A, F, and D. Okay, and then this is a 5, and then this is the A. Okay, right. So this is the answer lah. Right, the answer you can see. We have a lot of here. So this is some mistake lah. We can please double check your answer. So because of when you convert into this one, so maybe some mistake. Just maybe missing on the 0 or the 1. So that's why you have to double check, because easier to do a simple mistake. Even your this one is a try, for example, and then when you write the answer here, so maybe you have missing here 1. So for example, here we have 1 2 3 4 5 6. Okay, 5 6 1 here. Suppose we have 6. Maybe when we do the simple mistake, we just miss another 1 lah. So another 1 here. So the answer will be wrong. So that's why you have to double check lah. That mentioned to you. So this subject is easy, but also easier to do a simple mistake lah. Okay, so this is same like before this. So just split by. Okay, so this is what is the example? This one, the answer here, and then convert into binary. This one convert into binary, and then this convert into binary lah. Okay. Okay, this one I think you can try lah. You can try. Okay, you can try using your calculator. Okay, for example, you have the C. C, what is the answer? 1 1 0 0. Okay, and then 2 will be 0 1. Okay, 0 1 0 0. And then for the 5, 1 0 1 0. Okay, and then for 8, 1 0 1 0, and then for the 3 will be 0 0 1 1. Okay, and then you can write like this lah. Okay, right. So this one, okay, and then this one is the convert from hexa to binary. Okay, hexa to binary. Yeah. So this is solution lah that I mentioned to you, but this one is a alright. So we have 2 here, and so this one suppose this one will be 0. Okay, this is typo lah. Okay, if we put 1 0 1 0, so will be A actually. Will be A. So this one will be 2. 2 will be 0 0 1 0. So this is some typo lah. That's why you have to double check the answer. So the answer will be okay. So this one will be 0 lah. 0 0 1 0 0 1 0, and then 0 1 0 1. Okay. So this is some typo that you can write on your slide. Okay. Okay, so this is another example. I think this one you can I think we can straightforward. Okay, this one first. Okay, for hexa to octal, you can see hexa to octal. The first you have to convert into binary. So we have the, for example, this one. Okay, we have the hexa. You have to convert into binary. Then you can divide by 3. Okay, for example, you can get this one. For example, you have to convert into octal, but you have to first you have to convert into binary, then you can convert into octal. For example, from this one, A2 hexa convert into binary, you can get like this, and then you can split by 3 lah, by 3, because you want to convert into octal. Octal you have from binary to octal you can split by 3. Okay, kalau for example from binary to hexa we can split by 4, for example. Right, so and then you can convert lah. For example, 0 1 0 is a 2, and 1 0 0 is 4, and 0 1 0 is a 2 lah. So the answer will be 2 4 2 on the octal lah. Okay, so this is another example that you can try. So we have the answer here. You can double check. Okay, first step that I mentioned to you, just convert into into the binary. After binary, you just divide by 3. Okay, split by 3 lah, split by 3, then you can get the answer. Right, so this one from octal to binary, from octal to binary, to convert octal to binary, simply replace each octal digit with appropriate the 3 digit lah. So this I already explained before this. Just split by 3. Okay, for example, you can split here, and then you can this one convert into binary, this one convert into binary, and this one convert into binary, and then you can combine. So that is the last answer. Okay, for example, this one. Okay, for 1 is the 0 0 1, and then 4 will be 1 0 0, and then for 5 1 0 1, and then you can combine. So the answer will be 1 1 0 0 1 0 1. Okay, that is the answer lah, from convert from octal to binary. Maybe you can try this one. For example, we have 2 5 6. Okay, 2 5 6. Right, first you can use your calculator. Okay, we have the 2 5 6 in octal. Alright, so you want to convert into binary. So you can do like this. So 6 is the 0 1 1. Okay, 1 1 1. Okay, 4 2 0. Okay, and then sorry, this one is a okay, this is 3. Sorry, this one is for the 4. Okay, one 0 1 1. Okay, and then 0 1 0, and then this one is 0 1. Okay, 0 1. So that is the answer lah, right? Okay, the answer is 1 0 1 0 1 1 1 0. Okay, this one you can verify using your calculator. You can verify using your calculator. That's why after you convert manually, then you can verify the answer using your calculator lah. Okay, so this is another example. Okay, for example, we split by 3. Alright, so you can get lah the answer. For example, for 6 0 1 1. Okay, 0 1 1, and then for 7 1 1 1, and then for 4. Okay, for 4 is a 100. Okay, this one, for example, 3 split by 3. So this is a 4, 7, 6. And then you can verify using your calculator. And then this is another example. I think for this one, I think you can you have to practice using your calculator and using your manual lah. Okay, this one we skip first. Okay, so we same because of this slide too many example lah that you can refer after this. For example, this one from convert into hexadecimal. From hexadecimal, first dimension you have to convert into, for example, this one you have to convert into binary, and then after you get the binary here, so the answer is binary, and then from binary to hexa we split by 4, and I mentioned to you 1, 2, 3, 4, so split by 4. Okay, split by 4, one group, and then this is another one group. So this one will be get B, and then this one will be D, for example, and then in the hexadecimal. Okay, the step here similar like before this. So first step you have to convert into the binary. So and then you get the binary, then you can convert into hexadecimal lah. Alright, and then next you can convert decimal octal to decimal lah. So this straightforward using the that mentioned to you. So you can use this one, or you can use the division. So for example, you can use this one multiply. For example, this one 1, 4, 5. Okay, so this is power 8 or power 0. Okay, power 1, power of 2 lah. So this one 64, 1, 8. This one is a 1. Okay, and then you multiply lah. 5 multiplied by 1. Okay, 1 multiplied by 5, and then plus with 8 multiplied by 4, then plus with 64 multiplied by 1. So total out, you get the 101, 101 in the decimal lah. Okay, similar like this. Okay, this one after this you can try 34. Alright, point of 6, 8 in octal to decimal number. Okay, you can use this one. Similar like before this, you can use this one and then sum up the total, you can get the answer. Okay, so next, make sure you try this exercise. Alright, so after this you can try this exercise. Okay, first you can use your calculator, then you can use the manual lah. Okay, or you can try first, you can use the manual, then you verify using your calculator. Okay, after this you have to try lah. So because of tomorrow we don't have any also tomorrow we don't have the class because we still not finish the for chapter 1. After finish chapter 1, I will go for the tutorial. Then we have another extra class on the Friday. But now I'll try to finish on the chapter 1 first. Then we have the tutorial 1. On tutorial 1, we will cover for chapter 1. That is normally that our flow on my class. For example, I will try to finish the chapter for every chapter. For example, chapter 1. Then we have the one slide for the tutorial. And then we go for the chapter 2. I try to finish on chapter 2. Then we have another slot another one slot on the tutorial 2 So on the tutorial, so we have the tutorial question. So maybe I will ask. Okay, this one normally we can try we can try solve in the tutorial. If you have any problem, you can discuss on the tutorial class Okay, but on the lecture, so I will explain on the theoreticals, on the some example. Then for the tutorial, we will go for the tutorial question on the tutorial, so we can do one by one. Okay, this one make sure you can try this exercise at after this. Alright, so already give the answer, but make sure you can double check maybe we have some mistake maybe typo maybe some typo, that's why you have to double check is it a correct or not answer. So this is already give the answer in the slide. Okay, you can try and then double check the answer is it correct or not. If not, so maybe you can ask me Alright. Okay, so next we go for the binary arithmetics. That means we have the addition, okay, subtraction, multiplication, division So this is for binary binary arithmetics. That means digit power base 2 This 2, that means 0, 1, 0, okay, plus 1, 1, 1, for example. Okay, so this is arithmetic lah for addition, subtraction, multiplication, and division. Okay, so we go for addition. Addition, I think straightforward lah. Okay, for example, we go here. 0 plus 0 will be 0. Okay, 0 plus 1 will be 1. Okay, 1 plus 0 will be 1, and then 1 plus 1 will be 0, but carry 1. Okay, here you can see this example here lah. Right, so this 0 plus 0 will be 0. 0 plus 1 will be 1. Okay, 1 plus 0 will be 1, and then 1 plus 1 supposed 2 kan? Supposed 2. Okay, kalau for example for decimal is the 2 here. Alright, 2 convert into binary will be 1, 0. That's why you can see this one. So that's why we put 0 here, and then we bring carry here. So here, that's why suppose in the decimal, so this 1 plus 1 will be 2, but this one is in the binary, so we convert 2 into binary will be 1, 0. That's why here 1 plus 1 will be 0 here, bring the carry here. Okay, carry 1 here lah. So 1 1 carry here, then 1 plus 0 will be 1. So that's the answer, 1, 0. Make sure 1 plus 1. Okay, for example, we have 1, 1, 1 plus 1. For example, this one. And then, okay, we have 1 plus 1 will be 0. And then bring 1 here. Bring 1 here. Okay, 1 plus 1. Okay, 1 plus 1 will be, and then will be 1 plus 1 will be 0, and then plus 1 will be 1. Right, so bring 1 here lah. Okay, so then 1 equals 0. Okay, so something like this. Alright, so this is the answer lah for addition. But you have to remember this one. 1 plus 1 will be 0, but carry 1 here lah. Carry 1 here. So similar like if you are convert into decimal, 1 plus 1 will be 2, but 2 we convert into binary will be 1, 0. So 1, 0. It means 0 will be here, and then carry the 1. That is for addition. Addition. And then, okay, so this some example lah. Okay, we go from example 0, 0, 0, 1, 1, 0, 1, 0, plus 0, 0, 0, 0, 1, 1, 0, 0. Okay, so you can see 0 plus 0 will be 0 here. Right, so 1 plus 0 will be 1, 1 0 plus 1, 1. Okay, 1 plus 1 will be 0, carry 1, carry 1 here. Right, so 1 plus 1 is 0, then carry 1 here. Right, and then 1 plus 0 will be 1. Okay, and then this is 0, 0. I think this one addition is straightforward. Straightforward. Okay. Alright, so you can see this one. So this part. So 1 plus 1. Okay, this is same lah. Okay, maybe this one I will explain. Okay, 1 plus 1. Okay, 1 plus 0 will be 1 here, and then no bring. Okay, so 1 plus 0 plus 1, 1. Okay, 1 plus 1, 0, bring 1 here. Okay, that's why I mentioned to you. 1 plus 1, 0 plus 1 will be 1, then bring 1 here. Alright, so 1 plus 0 will be 1. Okay, and then 0 plus 1 plus 0 will be 1. 0, 0, 0, 1, 1. Okay, 0 here will be carry 1 here lah. Carry 1 here, and then 1 plus 0 will be 1 here. So that is the answer lah. Okay, so this is straightforward for addition lah. Okay, next we go for the subtraction lah. Okay, subtraction. Alright, you can see this one. So 0 minus 0 will be 0. Okay. Alright, so next I will skip this one first. Okay. 1 minus 0 will be 1. Okay. And then 1 minus 1 will be 0. Okay. But if this one, if 0 minus 1, you cannot lah. So we have to borrow. We have to borrow from, suppose we have the more significant bit lah. You can see, borrow from more significant bit. Maybe we have here 1 here. So for example, we have here. Okay, and then we have to bring here, so this one will be 0, and then this one automatically will be 2. Okay, this one, or we can declare as the 1, 0, 1, 0, or in decimal is a 2. 2 minus 1 will be 1, or 1 over 1, 0 will be 2, minus 1 will be 1 here. Okay, this is the difference. Okay, so you can see the example here. Right, so you can see we start from here. 1 minus 1 will be 0, 0, 0, 0, 1. Okay, this one this one will be 0. Okay, you can see this one. So this one 0, 1 cannot. So we have to borrow from more significant bit here. And then this one will be 1, 0, or you can declare as the 2 lah. 2 minus 1 will be 1 here. Or 1, 0. 1, 0 actually is in decimal is a 2 lah. Okay. 1, 0 minus 1 will be 1, and then this 0, 0 will be 0, 0. Okay, so you can see another example here. Okay, 1 minus 0, 1. Okay, 0, 1 minus 1, 0. Okay, this one cannot. This one cannot. We bring this one, cannot, also cannot. Okay, this one also cannot. Okay, here we can. Okay, this one we can borrow from this one. Okay, this one will be 0, and then this one will be bring to the 2. Okay, and then we borrow to here, so this one will be 1, and then this one will be 1, 0. Okay, or 2 lah, we can take 2. Okay, 2 minus 1 will be 1, and then this one 1 minus 0 will be 1, and then this one 0 minus 1 cannot, so we have to borrow from this. Okay, from most significant bit here, we borrow this one, and then this one will be 1, 0. Okay, 1, 0 minus 1 will be 1, and then the rest will be 0 lah. Okay, 0, 0, 0, 0. Okay, so that is the answer. That's a simple for binary arithmetic for addition, for subtraction, and you can see on the multiplication. Multiplication is straightforward lah, similar like binary, similar like addition. Okay, similar like addition lah. So 0 multiplied by 0 will be 0. 0 multiplied by 1 will be 0. 1 multiplied by 0 will be 0. 1 multiplied by 1 will be 1. No carry or no borrow lah. Okay, no carry or no borrow. Right, so you can see this one. So that's just a difference between the additional and the subtraction. So just multiply. So this some example 0, 1, 1, 1 multiplied by 1, 1. So first you have to multiply this part lah. Okay, this part multiply 1 by 1. Okay. Okay, so the answer will be 1, 1, 0, 1. And then this part same lah, 1, 1, 0, 1. So and then you can use the addition addition for this one. This one 1, this one will be 1 plus 1, 0, bring here. Okay, bring 1 here. So 1 plus 1 will be 0, bring 1 here. 1 plus 1 will be 0, bring 1 here. And then 1 plus 1 will be 0, bring 1 here. So basically this is the answer lah. 1, 0, 0, 0, 0, 1. Okay, that is for multiplication. First you have to multiply. I think it's similar like the decimal lah. It's the decimal number, so we implement the same step lah, the same step. Okay, for this is some example lah for the multiplication. Alright, I think the same slide. Okay, so this is some example. You can see this example. So I think this one you can try at home lah. So this one I will not explain detail, so you can do one by one. Okay, also you can this another technique lah, another method. Okay, for example, you can see 8 plus 8 or 8 multiplied by 8 multiplied by 8, or you can see like this 8 plus 8 plus 8 lah. So this is another example lah. Binary multiplication is the same as repeated by binary addition. Add the multiplication to itself the multiplier number of time lah. Right, so this is some example lah. For example, we have the 3 multiplied by 8. Okay, or we can add 3. For example, you can add the 8 plus 8 plus 8 lah. Right, so this is for the division. For division, the rule of division, binary division is the similar like decimal point. Okay, you can see the binary division is a repeated process of subtraction, just in decimal division. Alright, so for example, we have 1, 1, 0, 1, 0, 0, 1, 0. Okay, divide by 100. So I think it's similar like decimal lah. So it's a multiply 100 multiplied by 1 here, So we get 100, and then so this one you have to use the subtraction, and then you can get 1 0, and then you bring here 1. So I think this is simple mathematics lah. So 100 multiplied by 100, and get the remainder here. So remainder here, bring 0. Okay, so and then 0, then so on. So I think this one is similar like decimal lah, similar like decimal. Okay, so this one you can try lah. You can try, right? So this one from okay, this apa 0 0 1 0 1 0 1 0 divide by 1 1 0 lah. Okay, 0. So the answer will be this is the answer lah, 0 0. So you can check the answer lah. That's why you can, after this maybe you have to try how to divide division using the binary binary numbers. Okay, so this is another example. I think I'll not go through detail on this one. So this one I think you should try lah. You should try how to get the answer, and then double check, is it the correct answer. For example, this is the answer lah. Okay, so you can double check, is it the correct or not. Maybe you have some typo or some mistake in our answer. That's why you have to double check lah. Okay, so this is the exercise that you have to try, and also already give the answer. Okay, this one already give the answer. Alright, so this one after this you can try. So tomorrow, because tomorrow we don't have any tutorial yet, so I'm suggest to you to try expand. Okay, because our for Friday we have our class actually from 8 to 10. So maybe after this, maybe you can spend 1 hour lah, maybe at 9 to 10, try this exercise, okay, for tomorrow lah. Because no formal class, but you can do just follow the schedule lah, because we are free on tomorrow morning at 8 to 10. So maybe tomorrow you can refresh, okay, try this exercise 1 and exercise 2, and then double check the answer lah, is it correct or not. Okay, so we have another half an hour. So this one I will leave it to you. So you have to try after this, maybe tomorrow, okay, tomorrow morning, because we don't have any formal class, okay, for tomorrow. Okay, but I will go for the chapter 3, part 3. So maybe you have half an hour. Okay, I will explain a little bit on the until the first complement lah, Okay, so next we go for the chapter 1, part 3. Okay, part 3 is still in the numbering system and codes. Okay, so we go for the alright. So on this part we have the introduction, analog versus digital. I think I already explained to you what is the difference between analogs and digitals. Alright, so base number, alright, we already explained before this, and conversion, and then binary arithmetics. Okay, we have the addition, we have the subtraction, we have the multiplication, and we have the division. So now we go for the sign number, and arithmetic operation of the sign number, digital coded and digital coded parity. So today we just go for the sign number lah. We go for until the sign number, and then next week we go for the arithmetic operation and digital coded. Alright, so actually, so why we need the sign number? Okay, actually we need sign number because we want to represent if we have the negative. Okay, because of our digital technology, for example, for the computer, normally computer cannot recognize the negative number. So that's why we need some sign number to recognize, okay, this is the negative number. For example, okay, so we have okay, we have value here 11101. Okay, so this is positive or this is a negative, for example. Alright, so if you have sign number, you have the sign number, so we know this is positive. For example, for decimal, okay, this is we call the positive value. Okay, for example, we have here 10111. Okay, so this we have we can declare as the negative value. That's why we need some sign number to represent the negative, because I mentioned to you the digital on the computer they can recognize the digit, the negative sign. That's why on the computational in decimal, simply attach the minus sign of the front of the number to show the negative. For example, in decimal, this you can see on decimal. All right, and there's decimal line. Decimal automatically we put here, so we know this is negative. All right, and then for example in decimal, this is negative value. But in binary, so how you want to know? So this one, okay, for example, this is a positive value or this one is the negative value. That's why we need some sign number to represent this is positive, this is negative value, right? So since computer work with the 0 and 1, I mentioned to you for binary, so modification is required lah. So we call the sign number. So we put some extra digit in front of the binary number to indicate whether the number is positive or negative. So that's why we call the sign number, or we call the sign bit. All right, so you can see the sign bit here. If the number is positive, the sign bit is a 0 here. Okay, for example, right, so I put two example 0 1 1 1 0 1 1 So okay, if the sign bit is a 0, then the value is a positive. Okay, so the number here so the 0 on the front, okay, on the front on the binary we put 0 here. That means this is a positive value. Okay, this is positive value. That means this initial in the initial front is the sign number. And then if negative, all right, so the sign bit is a 1. So this one so this is declared as the negative value, right, in the negative value. So for example, we have another example here, 1 0 0 1 1 0 1 1 1. So automatically, so the in front sign bit you know is the is the 1. That means this value is the negative value. This is negative value. For example, we have 0 1 1 0 1 0 1 1 1. Okay, so this is a positive value. Okay, you know this is positive value. But when we implement the sign number lah, okay, if not, so it's just a similar like binary number. But we put some front number here, okay, the sign bit here. So automatically you have to know lah. So this number actually you want to represent this number. Okay, for example, I draw like this. Okay, we have like this. Okay, 1 0 1 1 So actually, okay, for example, we have this is we call the sign bit. Okay, so this to represent the negative, the value here. All right, the value is a 3. So that means this is the negative 3 on the decimal. Okay, this one for example in decimal in decimal point is a 10 All right, so this is value for negative 3, represent the negative 3. So this is for we call the sign bit. Okay, sign bit or signers, okay, to declare this is number for negative, and then this is the value lah. Okay, the magnitude of our numbers is the 3. Okay, 0 1 1. Okay, this is a 2, this is 1, this is 4. All right, this is 4. That means the total is the 3. That means the answer will be negative 3. Okay, so the negative 3 will be present like this. Okay, or maybe we have 0 1 1 1. Okay. Alright, so this is if we put this sign bit, this means our value will be positive. Okay, this one, this is a positive. Alright, so we can plus okay, so this is positive 7. Right, so if we have this one, okay, some example like this one, so we know this is a sign bit, that means it's the negative, and then this is value. So this is negative 7. Okay, this is negative 7 Alright, so this is represent the sign bit represent the negative. So we have to remember this one that I mentioned to you. For example, like for decimal, we can automatically declare as is negative. So we know, okay, this value is the negative. But in binary, or hexadecimals or something like for example, like for the binary lah, actually for binary. So how we know this number is negative? How this number is the positive? So we introduce we call the sign bit to represent the negative or positive value. So we put on the front so front binary. For example, like this one. So 0 will be represent the positive. You have to remember 0 will be present the positive and 1 will represent the negative value. Okay. This one you have to remember lah. So if negative, the sign bit is the 1. If positive, the sign bit is the 0. Okay, this one we call the sign magnitude representation lah. So this one need to specify how many bits the number, because a certain bit will represent the sign lah. Okay, that's why you have to know. So normally in our bit you can follow like this. Alright, so you can see for example binary we have like this one that mentioned to is a sequence This is a sequence for bits. Okay, this is 2, this is 3, this is 4. Okay, actually this we call 1 bit, this is a 2 bit, this is 4 bit, this is a 8 bit, this is a 16 bit. That's why you can see on our, for example, like our pen drive, okay, our hard disk, they have the 1 bit, okay, 1 gig, okay, for example 2 gig, 4 gig, 8 gig, 16 gig, 32 gig, because of based on 2 lah. Okay, for example 5. Alright, so this is really 32 gig. Okay, really next is a 6. Okay, it's a 64 bits. Okay, that's why you can see the how this very important the bits. Okay, so that's why you can see on, for example, like our pen drive, okay, like our hard disk, the represents 1 gig, okay, 2 gigs, 4 gig, not 3 gigs. No, I think you can see the 3 gig or 5 gig. So normally 1 gig, 2 gig, 4 gig, 8 gig, 16 gig, 32 gig, 40, 64 gig, and so on. Okay, and until power 7, power 8, and so on. Okay, so normally they represent like this lah. Represent like based on 2 lah. Okay, base 2. Right, so this one they mentioned to you. So for 0 will represent the positive and 1 will represent the negative. Okay, so this is the value lah. Okay, so for example, the front one is the, we call the sign bit. This one we call the sign bit. Okay, then this is a value value, for example, value for 25. Okay, this is 25 to represent. Okay, so this is the same. Okay, same value, same magnitude, but the difference of the sign lah. So this one is positive, this one for the negative. Okay, so it's 25 positive and this is negative 25. Okay, so you can see the difference. Alright, so normally they put on the most significant bit to indicate the sign that I mentioned to you. The most significant bit we put as the sign bit lah. Okay. So this one alright, so this one I think is the same, so that's why you can convert lah. Okay, you can convert from, okay, so we have the for example we have the value 5 here, 0 1 0. Okay, 0 1 0 1 is a 5, but how to put this one as the negative 5? So we put another one here lah, so another one here, change here to be negative 5, similar like 1 So 1 value is a 0 0 0 1, and then we put here 1, so automatically the value will be changed to negative 1. Okay, the magnitude will be same, it's a 1 here, 1, but the sign is this one is the positive and this one will be negative. Okay, you just refer. For example, we have another example. Maybe we have 1 0 1 1 0 1 1 1. Okay, for example, this is a negative negative. You can declare this is negative sign, and then you can put this is the magnitude what is the value for this one, right? So for example, we have 0 1 1 0 1 1 1. Okay, in binary convert into decimal, so we have negative 52. Okay, right, so that is the answer for example. So this represent the negative, and then this is represent the magnitude. Okay, so this is some example you can see. So the difference between the positive, okay, this is positive value, and then okay, and then this is negative value just change on this part. Okay, this is the same. This is value is for 127, and also same is also 127. All right, but the difference is the sign. So this is positive and this one is the negative. Alright, so next we go for first complement. We go for until first complements. Okay, so the first complement and second complement can be used to represent the negative number lah. So another method, we can use the first complement or we can use the second complement lah. Alright, for the first complement is changing all the bit from 0 to 1 or from 0 to 1 or 1 to 0. That means for simplicity we can declare as the invert the input. Okay, invert the input. For example, input 1 will be 0, 0 will be 1. Okay, that's why we call the first complement. Okay, you can see the example here. Alright, so for input 1, okay, change to 0. Okay, invert. Okay, invert the input. Input 1 will be 0, 1 will be 0, 1, 0, 0. Okay, so 0 will be 1, 0 will be 1, and then 1 will be 0, and then 0 will be 1. Okay, that's we call the invert the input. For example, we have 1, 0, 1, 1. So will be invert. So this one will be 0, and then this one will be 1, and then this one is 0, 0. Okay, that we call the first complement. Okay, this one. Another example here, we have 0, 1, 1, 0, 1, 1. Okay, so from this one, we use the first complement, just convert directly. So this one will be 1, this one will be 0, this one will be 0, this one will be 1, this one will be 0, and then this one will be 0. Okay, this one we call the first complement. The first complement. So for example, we put value here. So normally we can put as the, for example, we declare this one, this value is the A lah. A. The complement of A, normally we put some bar here. That means invert of A. Invert of A lah. For example, this value we can declare as the A. A. So when we put the complement, that means we put some bar here. Okay, that means invert the input. Invert the input A lah. So for example, the input A here 0, we invert will be this one will be 1, invert will be 0, and then like this will be 0, 0, and so on. Okay. Maybe we have another example here. So we have 1, 1, 0, 1. So automatically straightforward. For first complement, when implement the first complement, so this one will be straightforward 0, 0, 1, 0. Okay, straightforward. So for example, we have a lot of numbering for 0, 1, 1, 1, 0, 0, 1, 1, 1. Okay, automatically. So just straightforward, invert the input. So this one will be 0, 1, 1, 0, 0, 0, 1, 1, 0, 0, 0. Okay, straightforward. No need to use your calculator. For first complement, just invert the input. No need to use your calculator. Straightforward. Okay, just invert the input. For example, this one 1, invert to 0. So 0 invert to 1, and then 1 invert to 0, 0, 0, 1, 1, 0, 0, 0. Okay, that is for, we call the first complement. Okay, the first complement is a way to represent the sign number in computer. Alright, so it's obtained by inverting each bit. Okay, that I mentioned here. Invert the each bit. That means invert the inputs of the each bit of the corresponding positive number. Okay, you can see this one. For example, we have the positive. We have, you can see 5 here. 0, 1, 0, 1. Okay. For example, how to convert? Okay, if you use the first technique, that means we know this one will be okay, this one will be positive. This is the value 1. Alright, so if we use the second complement, you can see second complement, this one will be 1, and then this one will be 0, this one will be 1, and then this one will be 0. Okay, it will be like this. Okay, this is for first complement. The first complement. I think it will be like this. Okay, so you can see this one. So this is for example, we have the positive 7 here, positive 7. So this is the magnitude, and this is the sign. Okay, and then so if you use the, for example, we use the first complement, 1, 1, 1. Automatically, this one will be over into 1, 0, 0, 0. Okay, so will be same like this one. Okay, you can see. So this is another technique. Okay, another technique. Before this, we just use the straightforward using the sign bit. Okay, sign bit. So this one to use the first complement, first complement to convert to declare or to detect whether this number is a positive or negative value lah. For example, okay, we put here, so we know this number we represent as the -7 based on the first complement lah. This one based on the first complement. Right. So next we go for the second complement. Second complement, actually first we have to implement the first complement, and then the last part, okay, the last part we add 1 at the least significant position or least significant bits lah. Right. First we have to implement the first complement. This is the step for the second complement. For example, I will show the example. So we have 1 0 1 1 1. So this is another example here. Alright, so first complement. Okay, so we do the first complement. Alright, so this one will be 0, this one 1, this one will be 0 0 0. Okay. Alright, so for second complement we just add 1 here at the least significant bit. Here we add 1 here. So 1 plus 0 will be 1. Then 0 0 1 0. That is the answer. This is we call the second complement. Okay, this is the value for second complement. So maybe I will try another example here. Okay, we have the 0 1 1 1 0 1 1 1. Then okay, try to do the second complement for this number. For example, first step you have to remember, for second complement, first we have to do the first complement. Okay, first complement. So this will be changed. Okay, invert the input. So this one will be 1, this one will be 0 0 0. Okay, it's right here. All right, so this one will be 1, this one will be 0 0 0. Okay, and then for second complement we add 1 at the least significant bit here. Alright, so this is the 1 plus 0 will be 1 0 0 1 0 0 0 1. That is the value, the final answer for second complement. That is the final answer for second complement. So maybe you can try another example here. I think second complement is also straightforward lah. For example, we have a 1 1 0 1 1 1 0 1 1. So the first complement. So for second complement, we have to know the first complement lah, because for second complement based on the first complement lah. Okay. The first step we have to do first complement. That means this one will be 0 0 1 0 0 0 1 0 0. Then for second complement, we add 1 at the least significant bit. Remember, at least significant bit lah, here, the last position here. And then 1 plus 0 will be 1 0 1 0 0 0 1 0 0 lah, for example. Okay, so maybe I put example like we have the 1 at the back. So 1 0 1 0 1 we have to convert 0 0 0. Okay, for example this. Alright, so this example 1 0 1 0 1 0 0. Okay, so the first complement you have to invert the input. So this one will be 0 1 0 1 0 1 1. Okay, and then for second complement we put 1 here. Okay, 1 here. So 1 plus 1 will be 0. Okay, bring 1. Carry 1 here. 1 plus 1 will be 0. Carry 1 here. And then 1 plus 0 will be 1 1 0 1 0. So this is for second complement. This is second complement for this one. Alright. Okay, class, here this one for second complement and first complement. Okay, for the first complement, just straightforward. Okay, you can invert the input. That means if get the, for example, if you have the 1, just invert invert the input, that means you have the 0 and so on lah. And then for second, okay, for second complement, you have to do the first complement, then add 1 at the least significant bit. Remember, add 1 here. At least significant bit. At least, not here. Okay, not here. This one is the we call the most significant bit. Okay, you have to add on the least significant bit. Least significant bit here. Alright, so this is I think is a similar. Okay, so this is for example, this is a sign bit that I mentioned to you. Okay, so this is to represent the positive value, and this one to represent the negative value. But this one is the magnitude or true binary. Okay, this one normally I call as the magnitude the magnitude to present the binary form. Okay, sometimes we call the true binary, but this one is the value of the numbers the value of the number. For example, this one when we convert, we get the 45. Okay, and then this one is the sign bit, either the positive or negative. Is put the 0 will be positive, and then we put 1 will be negative. Okay, so this is another example. Okay, you can check this one. So this is untitled method. So I think it will be same lah. Right. So this is find the second complement. Right. So okay, you can use this number. So you can use this technique lah. So I think if you are you can use that I mentioned to you. So for example, we have 1 0 1 1 1 0 0 0. Okay, you can use before this technique that I mentioned to you. First, you can first complement 0 1 0 0 0 1 1 1. Okay, and then for second complement, okay, plus 1 here. Okay, so 1 plus 1 0. Okay, carry 1 here. 1 plus 1 0, carry 1 here. 1 plus 1 0, carry 1 here. 1 plus 0 1. Okay, this one 0 0 1 0. So that you can check the answer. Will be same lah. Okay, will be same. 0 1 0 0 1 0 0 1. So this is another alternative. So this is another alternative. But you can, for me, better you can use this one lah. First you have to convert into first complement, then for second complement just add 1 at the least significant bit, then you can get the answer lah. So this is for second complement. So this is another alternative lah. Okay, change all bit to the left of the least significant bit to get the second complement. So this is another technique lah, another technique that you can use. Okay, you can use for convert. Okay, to convert the number to the second complement. So you can see to the left. Okay, this one. Okay, this one. This one, the left least significant significant A to get the second complement. So this one. That's why you can get the answer. Okay, so this is an example. Okay, so right, so this is for second complement. Okay. Okay, so I think I will stop here. So until the second complement. So next week we will go for the next topics. Alright, so if there are any no questions, so maybe you can tomorrow you can try. You can try the exercise 1 and 2, and also you can try the tutorial. So the tutorial I already upload to MTeam on the folder. The both folder I also give the tutorial, maybe different tutorial. That's why you can try. You can try the both tutorial for the BEKU or BNNG. Okay, that's why I give 2 example for the tutorial. That's why you have a lot of example to try, and then you can do some exercise because this topic is not tough. Okay, for numbering system, but like I mentioned to you, it's easier to do the tally mistake lah. That's why you have to try more exercise so that you can understand and to avoid the tally mistake lah, simple tally mistake. Okay. So any questions so far? Guys, okay. Still no, sorry, I'm not read the meeting chat. So because I'm open the slide, so I'm not sure. Guys, okay, guys, but some of you, I think maybe your line. Okay, who might. Wait, wait. I will take your attendance first. Okay, so I'm not